Namaste and a very, very good morning to all of you. My name is Mithun, and in today's video, I'll be discussing how to perform hierarchical cluster analysis using IBM SPSS. When the sample size is extremely large, we do not use hierarchical cluster analysis. Let us say the sample size is in excess of 1000, then we prefer to use k-means cluster analysis. But what happens when the data is very, very small? Let us say the sample size in the data set is less than 100. For small samples, we do not prefer to use k-means cluster analysis. This is where hierarchical cluster analysis comes to our rescue, because hierarchical cluster analysis can be used when the sample is extremely small. How hierarchical cluster analysis works is it computes the distance, and based on the distance measure, if the distance is very, very small, it clubs those two data points. On the other hand, if the distance is very, very high, it obviously cannot put these two data points in the same bucket. So it will put them in two different categories. So this is how hierarchical cluster analysis works. I will be working on the car sales data set. To give you a glimpse of the problem statement here, let me introduce you to the background. Car manufacturers need to be able to estimate the current market. The question is, why is it that the car manufacturers find the need to estimate the current market? Because they need to determine the likely competition for their vehicles. If the cars can be grouped according to their available data, this task can be largely automatic using cluster analysis. What is the aim behind this analysis? The aim is to group the highest selling automobiles according to their prices and physical properties. The data set that I have is what is called as cars data set. And the methodology that I'll be using for this particular experiment is hierarchical cluster analysis. With this introduction into the data set and the problem statement, let us quickly jump to IBM SPSS. So this is the main screen of IBM SPSS. Let me pull the data set, which is called as car sales data set. I'll click on the file menu, choose recently used data. What SPSS does is it displays the 10 recently used files. Right at the top, you see the data set, which is called as sales data set. Let me click on this particular data set, and you see the entire data set being populated in the data editor window. As you can notice here, the sample size is just 11. We have only 11 vehicles, and we want to group them based on price and physical properties. Let's look at the variable description. We have manufacturer of the vehicle. We have the model of the car, like Taurus, Focus, Civic, so on and so forth. Then we have sales, resale, the type of the vehicle. And if I scroll to the right side, you can see important variables like price, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, mileage. These are some of the variables that I have. All these variables I will be using to segment the cars. Now, with this description about the data set, let me proceed to demonstrate hierarchical cluster analysis. To perform the hierarchical cluster analysis, I will click on the Analyze menu, go straight to Classify option. You have different methods of clustering. I will choose the third item from the top, which is called as hierarchical cluster analysis. So let me repeat this. I'll go to Analyze, Classify, and then choose hierarchical cluster analysis. The moment I click on this, a new dialog box pops up. Here, I will segment all those variables based on which distance measures will be computed to identify those cars which are very, very similar. What are the variables that I will be using? I will be using price in thousands, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, mileage per gallon. All these are variables that I will push under the variables list. You also have what is called as label cases by. I will use the variable models because this uniquely identifies the row. At the right-hand side top corner, you see different buttons like statistics, plots, method, and save. I will choose the plots button. The very first option is what is called as Dendogram. Dendogram is very, very important because it gives us a visual summary of the cluster solution. With this, I'll click on continue. Then I'll choose the methods option. You can see here, the third option from the top is method. Let me choose the method option. Excuse me. In the methods option, you have three choices. The first option here is what is called as cluster method. There are different ways in which you can group. You can see here between groups linkage, within groups linkage, nearest neighbor. I'll choose the fourth item from the top, which is called as furthest neighbor. You can experiment with each of these options, but for the purpose of this video, I will be choosing furthest neighbor. So this is the first thing that I need to do, choose the cluster method. What is the second thing that you need to do? You need to choose the distance method. And there are a variety of distance measures here. I will choose the squared Euclidean distance. Lastly, I need to transform the values as well. So you have an option which is called as standardize. When I click on the drop-down menu, you see different options. I'll choose the second option from the top, which is to use the Zscores. So these are the three selections that you need to make so that you can kickstart the process of segmentation. I'll repeat this. First is choose the clustering method. Second, choose the distance measure. Third option is to choose the Z-score. You can experiment with different combinations so that you can get a decisive cluster. I'll choose continue. So in the plots tab, I have clicked Dendogram. In methods, I have chosen the segmentation method. I've also chosen other things like distance measure and standardization. The last option is what is called as save. I'll choose save and I will say single solution. Number of clusters here, if you want, you can specify either 2 or 3 or 4. The general rule of thumb is 5 plus or minus 2. When I say 5 plus or minus 2, what do I mean? I mean that anywhere in the range of 3 and 7, you can specify values. Either you can choose a 3 cluster solution or a 4 cluster solution or a 5 cluster solution or a 6 cluster solution or a 7 cluster solution. How many clusters do you need to make? That's a very, very subjective question. You need to take two considerations into account, both the statistical considerations as well as the business considerations need to be accounted for. But the general principle is 5 plus 2 or 5 minus 2. Anywhere within this range, that is between 3 and 7, you can give the number of clusters. So since I do not know for sure how many clusters are there, I will avoid specifying any option here. In the first trial, I'll simply click on cancel and then choose OK. Once I run the cluster analysis, in the output window, you can see different tables appear. Now, the agglomerate schedule, this is very important. This gives a numeric summary of the cluster solution. I will ignore this because whatever I am able to get from this table, I can interpret the same through what is called as a dendogram. A dendogram is very, very important, and it is also very easy and simple to use. It's a graphical summary of the cluster solution. So if you ask me what is a dendogram, it is simply a graphical summary of the cluster solution. What do you see in the dendogram? You can see here, you have the vertical axis. You can also see the horizontal axis. In the vertical axis, you can see the names of the cars. You have different models of car. I've already read out some of these things like Civic, Corolla, and you have other vehicles as well. And in the x-axis, what do you have? In the horizontal axis, what you have is the distance between the clusters when they are joined. I repeat, in the horizontal axis, you can read the description here. This is the distance. Now, what is the optimal number of clusters? As I already mentioned, this is a subjective, this is a very subjective question. Nobody can give you a formula based on which you can arrive at the ideal cluster. Now, what we can do is, starting from the right, you see there's a big gap between 15 and 25. And it is pretty decisive because the way the dendogram is formed, it appears that this method clearly splits the automobiles into two groups. So which are these two groups? From the top, you can see some of these vehicles like Accord, you can see Camry, you can see Cavalier, so on and so forth, up to Corolla. All these cars can be put in one group. All these cars can be put in one group. After this, you have a set of vehicles, and this is the second set of vehicles. You have vehicles like, you can see here, Grand Am, Impala, you have Taurus as well as Mustang, which you can put in the second group. So vehicles like Accord all the way up to Corolla can be called as the first segment. Then vehicles from Malibu all the way up to Mustang can be put in the second segment. Now you may ask me, on what basis are we grouping these vehicles? What is the similarity between the first set of vehicles and the second set of vehicles? If you look at the vehicles at the top, all of these vehicles are smaller cars. When you compare the vehicles at the top to that of the vehicles at the bottom, the vehicles at the bottom are larger cars. So based on the size, we can group the automobiles and we can make two groups. Vehicles at the top are all smaller cars. If you look at Accord or Camry or Cavalier, they're comparatively smaller as compared to some of the vehicles like Impala, Taurus, or Mustang. Now, within the smaller cars, you again see that there is a subdivision. You can further break these cars into two groups. Initially, we made two groups, that is smaller cars and larger cars. From the smaller cars, you can further split the automobiles into two groups. The first three could be Accord, Camry, and Cavalier. Then you have Focus, you have Civic, and Corolla. Focus, Civic, Corolla can be put in a separate group altogether. Accord, Camry, and Cavalier can be put in the other group. Now you may ask me, on what basis am I grouping Accord, Camry, and Cavalier? Very simple. The vehicles, the first three vehicles are small and economy cars. I repeat, the first three vehicles, namely Accord, Camry, and Cavalier, these are small and economy cars. While the vehicles at the bottom of the first set, namely Focus, Civic, and Corolla, these are smaller and cheaper vehicles. When I say smaller and cheaper, compared to the first three vehicles, they are cheaper vehicles. So this is the sum and substance of hierarchical cluster analysis. We've been able to divide 11 cars into two groups. First one represents smaller cars. The second represents larger cars. Within the smaller cars, we've been able to further break it down into two groups. The first three vehicles, namely Accord, Camry, and Cavalier, can be called as smaller and economy cars, while the other three cars, namely Focus, Civic, and Corolla, can be called as cheaper siblings of vehicles like Accord, Camry, and Cavalier. So this is how we can do a hierarchical cluster analysis. Now that I am clear that there are two groups of vehicles, let me go back to SPSS. This is the SPSS data editor window. I'll click on dialog recall. I'll choose hierarchical cluster analysis. You can see here, I had not saved the new variable. Now I will choose the cluster membership. Now that I know that there are two groups, I can go ahead and choose 2 as the number of groups. Let me click on single solution. Excuse me. When it comes to number of clusters, I can specify 2, click on continue, and then say OK. It will rerun the entire hierarchical cluster analysis procedure. I can scroll to the right side. You can see here, this is the new variable that has been created. I can right click and simply say sort ascending. You can see here, the first 6 vehicles belong to the first group, and you can also see the bottom 5 vehicles belong to group number 2. So this variable indicates the cluster membership. So to summarize what we have done today, we have performed what is called as hierarchical cluster analysis. We specified 3 different options. One is furthest neighbor method. We used Zscores. We also looked at how we can decide the optimal number of clusters using the Dendogram. With this, I have come to the end of today's video. If you have liked this video, please subscribe to my channel and hit the like button. Thank you very much for watching today's video. Have a great day.